Hi everyone, today we're going to be learning about bivariate data analysis. This is our new topic and it's a pretty exciting topic actually. It's really interesting and there's a lot that can be learned and is actually used in the world, particularly in the world of medicine. So just to introduce, we're going to be looking at sort of how to work with scatterplots, read and interpret and draw scatterplots. We're going to be doing an actual activity that will compare the heights and arm span lengths when we get back to working together. But in the meantime, we're going to be just looking at, I guess, constructing scatter plots to identify patterns, to look at the presence of what we call an association, and then also to be looking at justifying conclusions, looking at strengths, looking at linear, non-linear types of correlation and association, and also looking at real-world examples. So first question, what is a scatter plot? It's basically where we are plotting points comparing two variables. Okay, so basically where we have some sort of data. Some bivariate just means looking at two different types of things. Okay, so we're looking at bivariate data. Sorry about that. Getting the preview before the game. All right, try that again. So we're looking at bivariate data. So you just want to write this down in your booklet if you've got it or in your notes. So bivariate data where we compare two variables and plot these points on the number line, or number plane, sorry. Obviously, we'd still need to make sure we label our axes, titles, etc. So bivariate data is where we're looking at two variables. So for example, we could be looking at heights and weight, okay, and seeing if there's any kind of relationship between those two things. What kinds of relationships or correlation can exist? Well, there's different kinds of correlation or association that can exist, but we have what we call causal relationships and we have what we call non-causal. Okay, so causal is where one thing sort of induces the other thing to happen, and non-causal is where we've got two things but there's kind of no real pattern to them. So in this one there's a pattern, and I guess one influences the other. And in non-causal, there's sort of no real pattern there. It's just a bunch of data where you can still draw some ideas from and conclusions, but there's no real pattern. Biometric, I'm going to let you research that one, but that's really interesting. It's got a lot to do with the health field, and you can sort of tell from the word metric and bio what that's going to be. This investigation is a really cool one to do. I was hoping to do in our first lesson, but unfortunately I can't be with you. So when I get back, I'm looking forward to doing that one with you. What we will do now, however, is we're going to look at different kinds of relationships, or what we also call association. And generally in correlation, or when we're looking at scatter plots, we look at a couple of different things. Okay, we look at firstly whether a relationship is positive or negative. So if you think back to gradients, we've got positive, negative, stationary or zero, and undefined. Okay, so that's positive, negative, zero, undefined. Keep in mind these are gradients, so it relates to that. But we can also have, like, depending on how close and how far the dots are, all these points, they create a certain strength, if you like, of a relationship or strength of an association. So first of all, we want to know if a linear relationship exists. So that means, is it like a line? Okay. So for part I, in this one, we would say it's linear. So I'm just going to write L. This one would say it's linear. In fact, most of these are linear. This one is kind of just all over the place, so we'd call this nothing. This one would be non-linear because it's a curve. Okay. For E here, we say there's no relationship here, so we call this no correlation. But then the others, the strength of the relationships depends on how close the points are together or how far out they are. So, for example, this one here would be quite a strong association. This one here we'd probably say was moderate. This one here we would probably say was moderate as well, or moderate to weak. This one here would also be strong. If it forms a perfect straight line, we call that perfect correlation and has a correlation coefficient of 1, which we'll learn more about that later. This one here, it's nonlinear, but there is still a relationship. We'll probably say there's some sort of moderate non-linear relationship that exists. So you can have, there are 3 types of association you can have. You can have weak, you can have moderate, and you can have strong. Okay, so these are the 3 types of association that exist. All right, let's have a look at a typical example. It says the population of each suburb is counted along with the number of supermarkets in the area. So in this, we're looking at bivariate data. We're comparing population with number of supermarkets in that area. Okay. So in this question, we want to consider what it's asking us to do. Well, first of all, it's asking us to make a scatter plot and then use it to see if it's linear and whether it's positive or negative. In the HSC, you may also then get asked to state what kind of association exists, like if it's strong, weak, or moderate. So just remember with any table like this, the top is your horizontal, the bottom is your vertical. So down the bottom here, I'm going to have population times 1,000. And on the side here, I'm going to have number of supermarkets. So if you like, that's the frequency. And we would write there, supermarkets. So I've got to think about my scale now. So my number of supermarkets goes from basically 4 to 9. So you want to be using your whole graph as much as you can. I'm going up by ones for this on purpose. That's going to be my 0 mark there. And along the x-axis, I'm going up from 55 to 95. So you can decide where you're going to go from. I'm going to go by tens. Sorry, I did say tens and then I'm writing fives here. Bit odd. All good. Start again. Cool. So I've labeled my axes, I've labeled my origin. Then I'm just going to go through and simply mark out the points. So I'm doing, for the first one, I've got a 55 and a 4. So I'm going to 55. And then I'm going to 4. And what I'm going to do is I'm going to put a point there. Okay, then I'm going to go up and do the next one. I'm going to go to 65, then 4. Then I'm going to go to 65 and 6. And you'll end up with a beautiful scatter plot, and then you'll be able to draw some conclusions. So at 70, I'm at 5. Oh, I did that one in the wrong spot. Okay, at 75, I'm at 80. 75, I'm at 6, sorry. It's a bit hard to see on here. Okay, at 80, I'm at 8. At 85, I'm at 6 and 7. At 90, I'm at 8 and 9. And then at 95, I'm at 8. Okay, so that's my scatter plot. I'm going to give it a title. I'm going to go population and supermarkets. Per suburb. Something like that. And now I want to have a think about what it's showing. Okay, so I want to think about, is it linear? So I would say yes, it's linear. And then I want to think about, is the relationship positive or negative? Clearly it's leaning to the right, so it's a positive association. Or a positive relationship, and I'd probably say it's a moderate one, but they didn't ask for that, okay? All right, the next question is very similar, except I want you to know that this one is a nonlinear relationship. It doesn't ask us about that, but it's really important for you to see. Obviously, it makes a curve. And showing the length and mass of a dozen eggs. They must be some kind of big eggs if they're weighing that many kilos. Whoa. So what is the approximate mass of an egg that's 4.5 centimeters? So I'm going to go to 4.5 centimeters. I'm going to that dot, and then I'm going across here. And you can see when I do that, it's approximately, if that's 30 there, approximately 25. So I'm going to go approximately 25 kilograms. This is just reading and interpreting part. What is the approximate length of an egg that weighs 50? So I'm going to 50. Here it is. I'm going across to the dot, and I'm going down. It's approximately, I'm going to say maybe 5.8 centimeters. You know, there'd be a little bit of leeway here. Is the relationship strong, moderate, or weak? It's very much so almost in a straight line, almost all touching. So I'm going to say it's strong association. So just to recap, if you want to draw a scatter plot, you've got to do these 4 things. Have a look. Also write down a couple of other summary points. We learned about something called association. I was using that word in conjunction with the relationship of the correlation. I've been using the word correlation, which also means like relationship. We've been using the word bivariate, and I've asked you to look at biometric. So write down some other important things you think, and then you guys are having a look at 6A and 6B. Thanks guys, I hope to see you soon.